In question number 46, a pendulum bob of mass 80 milligram and carrying a charge of 2 into 10 raised to the minus 8 coulomb is at rest in a uniform horizontal electric field of 20 kilovolt per meter. Find the tension in the thread. So in this question, there is a horizontal electric field due to which there will be a horizontal force on the pendulum, and there will be gravitational force, that is mg. So here the electric force will be q times e, and what we have given, the charge is 2 into 10 raised to the minus 8 coulomb and mass is 80 milligram and electric field magnitude is 20 kilovolt per meter. So this is given. So if the angle, this string makes an angle theta with the vertical, so in this right angle triangle your tan theta will be equals to Fe upon mg. So if we put the values and we take g equals to 10, so let us take g equals to 10 meter per second square. So Fe will be q times e, q is 2 into 10 raised to the power minus 8 into e, that is 2 into 10 raised to the power 3 divided by mg, that is 80 milli 10 raised to the power minus 6. So it comes out to be, this is 4 and this is 2, so it will be 1 by 2, and we have to multiply with 10 also, then it will become mg. So this is mass and this is the acceleration due to gravity. So we have 10 raised to the power minus 5 upon 10 raised to the power minus 5. So your tan theta comes out to be 1 by 2. So the tension, if you take the FBD of this, so the vertical component will balance because it is in equilibrium. So if this is tension, T cos theta will be equals to mg. So cos theta will be, from here we can calculate cos theta, so it will be 2 upon root 5, that will be equals to mg, that is 80 into 10 raised to the power minus 6 into 10. So from here we can calculate the tension and it comes out to be, so it comes out to be 8.9 into 10 raised to the power minus 4 Newton. So this is the answer for question number 46. So in question number 47, a particle of mass m and charge q is thrown at a speed of u against a uniform electric field E. So there is a particle and इसको हमने throw किया है with the initial speed u, and the charge and the mass is given against an electric field. So electric field is in this direction and the particle is moving in this direction. How much distance will it travel before coming to a momentary rest? So electric field is in this direction, the force जो होगा particle पर, the force on the particle will be in this direction, and by Newton's second law, acceleration comes out to be QE by m. This is the force. So this acceleration will be against the velocity. So it will be towards left. So we have to find the distance it travel before coming to rest. let it covers S displacement before coming to rest. So we can apply S equals to ut plus half at square. Sorry, time is not given, so we will apply v square equals to u square plus 2as. So v square equals to u square plus 2as, because it has a uniform deceleration, so we can apply kinematics equations. So final velocity is 0, initial velocity is u, and acceleration is negative. So from here we can calculate s. So s will be v square minus u square upon 2a. So from here final velocity is 0, initial is u, and minus 2 qe by, and from here it will be u square m upon 2 qe. So this is the answer. In the next question, in question number 48, a particle of mass 1 gram and charge 2.5 into 10 raised power minus 4 coulomb is released from rest in an electric field of 1.2 into 10 raised power 4 Newton per coulomb. Find the electric force and the gravitational force acting on this particle. Can one of these forces be neglected in comparison with the other for approximate analysis? Let us see. So what we have given the mass is 1 gram and the charge is 2.5 into 10 raised power minus 4 coulomb, and the electric field is 1.2 into 10 raised power 4 Newton per coulomb. So this is given. So let us find the electric force. That will be Q times E, 2.5 into 10 raised to power minus 4 into 1.2 into 10 raised to power 4. Okay, so it will cancel out, and it will be equals to 3 Newton. Now the gravitational force, that will be m into g. So m is 1 gram, that is 10 raised to power minus 3 kilogram, and g is 9.8. So 9.8 into 10 raised to power minus 3 Newton. So we can see 9.8 into 10 raised to power minus 3 Newton is very less than 3 Newton. So Fg can be neglected in comparison with F. Okay, so this is the answer of first part. So this is your A. And in the second part, how long will it take for the particle to travel a distance of 40 centimeter? So now we will only take the electric force. So how long? So this is the particle. So there is suppose electric force in this direction. So how long will it take to travel a distance of 40 centimeter? So first of all we will find the acceleration, and acceleration will be QE by m, and it comes out to be 3 divided by 10 raised to power minus 3. It will be 3000 meter per second square. So we have to find out, and the particle is released from rest, so u will be 0, and we have to find, and displacement is 40 centimeter. So your particle, if it starts from here, it reaches here, so this displacement is given 40 centimeter, and initial velocity is 0, and we have to find the time. So we can apply s equals to ut plus half at square, because acceleration is constant, so we can apply kinematics equation. S is given, that is 0.4, initial velocity is 0, and it will be half into 3000 into t square. So it comes out to be 0.8 divided by 3000 square root, and it will come out to be 1.63 into 10 raised per minus 2 seconds. So this is the answer of second part. In the third part, what will be the speed of the particle after traveling the distance? So we want to find the speed. So in the C part, we can apply V equals to U plus AT. So it will be, initial velocity was 0, A was 3000 into 1.63 into 10 raised per minus 2. So it comes out to be 48.9 meter per second. So in the D part, how much work is done by the electric force on the particle during this period? So in the D part, work will be F dot displacement. Both are in the same direction, so it will be F into S, product of the magnitude. Force is your 3 Newton into displacement is 0.4 meter, so it comes out to be 1.2 joules. So this is the answer of part D. In question 49, a ball of mass 100 grams and having a charge of 4.9 into 10 raised to minus 5 coulomb is released from rest in a region where a horizontal electric field of 2 into 10 raised to 4 Newton per coulomb exists. Find the resultant force acting on the ball. What will be the path of the ball, and where will the ball be at the end of 2 seconds? So here what we have given the mass of the ball is 100 gram and the charge is 4.9 into 10 raised to minus 5 coulomb, and the electric field, which is horizontal, is 2 into 10 raised to 4 Newton per coulomb. So it is something like this. This is your particle and there is horizontal electric field, so due to which there will be an electric field in this direction, and there is gravitational force in the downward direction. So first of all, we have to find the resultant of these two forces. So first of all, we'll find Fe. So your Fe will be Q times E, and Q is 4.9 into 10 raised to minus 5, and E is 2 into 10 raised to 4. So it comes out to be 9.8 into 10 raised to minus 1 Newton, so which will be 0.98 Newton. And the gravitational force, which is Fg, will be m into g. Mass is given, that is 100 grams into 10 raised to minus 3 into 9.8, so it comes out to be 0.98 Newton. So both the forces have the same magnitude. If there are two forces which have the same magnitude, then their resultant is root 2 times the magnitude of any of the force. So if we multiply this, it will be 1.39 Newton, and it will makes an angle of 45 degree with the horizontal, because both have the same magnitude, so the resultant will lie along the angle bisector of the angle between the two vectors, so this angle has to be 45. makes an angle of 45 degree with the horizontal. Okay. So in the second part, so this is the answer of first part. In second part, what will be the path of the ball? So now this is the resultant. So this force is acting. So there is only one force is acting. So the path of the particle will be a straight line, and it will be moving in the direction of the resultant. So it will be a straight line along the direction of resultant. Okay. So where will the ball be at the end of 2 seconds? So after 2 seconds we can apply, since the ball is released from rest, so its initial velocity will be 0, and after 2 seconds we can apply S equals to ut plus half at square, and this acceleration we can find out as force upon mass. Mass is 100 grams. So the acceleration will be 13.9 meter per second square. So from here we can calculate 0 plus half into 13.9 into 2 square. So it comes out to be 27.8 meter. So this is the answer of C part. In question number 50, the bob of a simple pendulum has a mass of 40 grams and a positive charge of 4 into 10 to the minus 6. It makes 20 oscillations in 45 minutes. A vertical electric field pointing upward and of magnitude 2.5 into 10 to the power 4 Newton per coulomb is switched on. How much time will it take to complete 20 oscillation now? So यहाँ पर we have given there is a bob of mass 40 grams and the charge is also given, that is 4 into 10 raised to the minus 6 coulomb, and it takes 45 seconds to complete 20 oscillations. So something like this. This is your bob, and there is an electric field in the upward direction, that is 2.5 into 10 raised to the power 4 Newton per coulomb. So now we have to find the number of oscillation. We have to find the time taken for 20 oscillation in this new scenario when the electric force in the upward direction. This is the case when there was no electric field. So whenever we have such a situation and we have to calculate a time period, तो आपको यहाँ पर निकालना चाहिए सबसे पहले the tension in the string. So this is your gravity, and here there will be your electric force in the upward direction. So the tension comes out to be mg minus QE, and from here we have to calculate the G effective, and the G effective is given by the tension upon mass. So if I divide this by mass, I get G minus QE by M. So it will be 9.8 minus 4 into 10 raised to power minus 6 into 2.5 into 10 raised to power 4 divided by mass will be 40 grams. So this is the equation. So 2.5 into 4 will be 10. So we can say it will cancel out with this. And what we have, so this thing will become 2.5. So we have 9.8 minus 2.5. So it will be 7.3 Newton per kilogram. So we know that the time period of a pendulum is proportional to square root of the g. So we can write new time period divided by original is equals to square root of, that is your 7.3, and here it will be 9.8. So from here we can calculate new time period. So the original time period will be 45 divided by 20 and square root of 9.8 by 7.3. Okay, so now we have to find the number of time taken to complete 20 oscillations. So multiply it with 20. So time taken to complete 20 oscillations will be 20 into 45 divided by 20 and square root of 9.8 divided by 7.3, and when we'll solve this, it will become 52.1 seconds. Since all the values that are given are in two significant figures, so the answer will be 52 seconds in two significant figures. So this is the answer of question number 50. Thank you.